Alright, now welcome to lesson 4. It's only one page of notes, so it shouldn't take too much time. We're going to start off by filling out a chart comparing mass and weight. So first of all, what are the units for each of them? Well, mass is measured in kilograms, and the abbreviation for kilograms is simply kg. So wherever you see a formula that involves mass in our course, you should convert to kilograms. So if it's in grams, you should convert to kilograms. Weight, however, is measured in newtons. And the abbreviation for newtons is actually an uppercase N, not a lowercase one. So you'll see an uppercase N. Now, what is it? What is mass? Well, mass is the amount of matter, or we could just say the amount of matter or stuff that we have. Weight, now a good clue because it says the unit of measurement is a newton. It's the same as other forces. Weight is a force. It's the force of gravity. Oh, I can't spell very well. Let's try that one again. Gravity. There we go. What's the formula that ties these two together? Fg equals mg. And Fg, I think I went over this already, is equal to the weight, or force of gravity, m, no, the force is measured in newtons, m is the mass, and g, small g, is, well, there's a couple ways to talk about it. Let me just back up over here, or use a bit more room here. So we can talk about g in two different ways. One is, we can call it how strong the gravitational field is. Yes, there is such a thing as a force field. So we could say g equals gravitational field strength. And I know that's a lot of letters. So if you imagine, let's say this is the Earth here. The Earth sets up an invisible force field around it. So I can diagram that by showing some arrows. Okay, so this is the direction of the field. Okay, now if I place an object in the field, so here is an object I just placed in the field, that object will experience a force, the force of gravity. Okay, if I take this formula, Fg is equal to m, now this means m times g. Let me rearrange this to say g is equal to, if I solve for g, then I need to divide both sides by m. So I get Fg over m. And I'm doing this just to think about what would the units be for g. Well, the units for force is newtons, and the units for mass is kilograms. So the units for this would be newtons per kilogram. And so the gravitational field strength close to the Earth is approximately 9.8, but for today we're just going to call it 10 newtons per kilogram. So that means if I place a 1 kilogram mass right here close to the Earth, it'll experience 10 newtons of force. For every kilogram I put there, it'll experience 10 newtons of force. If I put 2 kilograms out there, 20 newtons of force, and so on. So you can think about small g as a gravitational field strength, and the units for that would be newtons per kilogram. Okay, I'll talk later in our course about fields. We have gravitational fields, we have electric fields, and we have magnetic fields. They are all actually quite similar. The second way we can think about that letter g, that small g right here, is to say that g is equal to the acceleration due to gravity. And the acceleration, and we've noticed this before, if we let something fall close to the surface of the Earth, it will accelerate at approximately 10 meters per second squared. I know some of you are saying it's 9.8. I'm just using 10 today because it's mathematically a lot easier to do the numbers in your head. Okay, so let's go on to these examples over here. A student has a mass of 70 kilogram. What is the student's weight? It's pretty clear. We're going to use our brand new formula here. We're taking it out of the wrapping paper. Fg is equal to m. I'm just going to put a little time symbol here just to remind ourselves that m and the g are multiplying with each other. Okay, so I've got a mass of 70 kilograms. So below mass, I'm going to put a 70. G, I'm going to assume from the question that this is taking place close to the surface of the Earth, so I'm just going to multiply that times 10. So my Fg is going to be equal to 70 times 10. So clearly my force of gravity is going to be equal to 700. Now if we would stop there, we would lose marks. Mr. Speiser would say, you got to remember units. So what are the units for the force of gravity? It is newtons. Now somebody out there might say it's a vector, we should include direction. So if we're going to do that, we could say 700 newtons down. But to be honest with you, most of the time I would be pretty happy if you just remembered the units. And if it's really obvious what the direction is, like force of gravity is always down, I'm not going to take away marks. But it makes me happy. It warms my physics teacher heart when I see someone putting a direction for every single vector. Let's do the second example and then we'll be done. It says an object experiences a force of gravity of 600 newtons down, hey, there's direction, and a tension force of 600 newtons up. Okay, well let's draw a free body diagram of that. That looks interesting. Here's my force of gravity downwards, and that's 600 newtons. And then upwards, I can tell it's up because the arrow is going up. There's a tension force, capital T, of 600 newtons. And we're asked to find what's the mass. Well, what's the relationship here? And actually, there's no reason to have tension. We don't even need it. It's just, as I mentioned in class, it's a red herring. It's some information that we don't need. So I'm going to write Fg equals mg. I'll write in what we know, that the force of gravity is 600. Our mass we don't know, so I'm just going to write m. And I'm going to use the shorthand. Instead of 9.8, I'm going to use 10 here. Now that looks a little bit weird because the m is first and the number 10 is second, so I'll just rewrite this. And then suddenly the algebra looks way easier when the number's out front. I know when it's written like this, some of you out there are tempted to subtract 10 from each side, but 10 is multiplying with m, so we need to divide it. It's a lot easier to see at this point here that we need to divide both sides by 10. So I'm dividing both sides by 10, in which case my right hand side simplifies to m, and my left hand side simplifies to 60. So I'm going to say that m is equal to 60. The units, of course, are kilograms. The direction, fooled you. Mass is a scalar, it has no direction. Tell you what, let's do this so that our teacher can find our answers really, really easily. Okay, that's it. So the worksheet is only one page, page 11, mass and weight, and the sublevel is number 6. Excellent. I'll see you in class.